Hello students, today we are going to discuss the first topic of our unit 1, that is Introduction to Computers. And please refer this textbook E. Balaguruswamy, Programming in ANSYS 6th edition. And this is the prescribed textbook. Students, after completion of this lecture, you will be able to illustrate the basic programming steps with the help of flowchart and algorithm. So initially we should see some salient features related to the elements of the computer. So basic elements of computer are uh, mouse, keyboard, monitor, memory, CPU, where motherboard will be there, hard disk will be there, right? And these are some uh, other auxiliary equipment which we require: speakers, modem, power supply, processor. And a computer performs basically 5 major operations of functions. First one, it accepts data or instruction uh, in the form of an input. Then it stores the data, and it can process the data as per the requirement of the user, and it gives results in the form of an output. And this total process is controlled inside the computer. So first 4 operations are controlled by the inbuilt operations which are in the computer. Now this is a block diagram of computer organization. We have memory unit, control unit, arithmetic logic unit, and we have input and output. There are other auxiliary modules, but these 5 are the major modules which actually runs a computer. So we shall see each one of them, students. As you know, input unit is the job of the input is to take the input from the program or from the keyboard over the digital communication lines. And whenever you type a letter or digit on the keyboard, it is automatically transmitted into the code which is understood by the computer. That means it will be converted into zeros and ones. A computer never understands our English language. So whatever button you press, okay, whether it is a text or number or any special operator, that will be converted into a machine understandable form, which will be in the form of zeros and ones, and then the processor will start processing the input. So RAM plays a major role here. RAM is a primary memory of the computer, which is random access memory. It can be used every time a computer processes the instruction. It is an active memory of the system, and the data which is stored in the RAM is for temporary storage. And once a program is executed or once a job is done, whatever data is present in RAM, that will be removed, and the RAM is made free. And it works with a very high speed than the normal memory. And in RAM, it consists of a large number of semiconductor cells, and those cells will store 1 bit of information. And when you group all these bits, each you have 1 bit over here, which will be taken care by one semiconductor cells. When you group all these bits, we call this group of bits as words. So it depends upon the processor that how many bits will be considered as one word. And main memory is organizing all these words that will be stored and retrieved with the help of some operations. And whenever we are storing this group of bits into memory as a word, it will be stored in the memory with the help of some address. Suppose here I am taking 8 bits is equal to one word. Right. So they will be occupying 8 blocks of memory. So this is stored as one word in the memory, and whenever it is stored in the memory, it is stored at some address location. So let us consider the address location is 1024. So whenever we are asking the compiler to print this word, it goes to this memory address. From this address, it takes this word and it displays on the screen. And data and programs must be in the primary memory for execution. That means they should be in always RAM so that they will be executed. And the next one is processing unit. So this is some most important module of the computer. And within this processor unit, we have arithmetic unit, logical unit, and control unit. Now, coming to the arithmetic and logic unit. So these are responsible for all mathematical calculations. So they suppose two numbers are located in the main memory to be added. They are brought into arithmetic unit. Actual addition is carried out, and then the result is stored in the memory, and it is again displayed to the user. So this is the purpose of this arithmetic and logic unit. Whenever you are trying to evaluate an expression containing some arithmetic operations or logical operations, then ALU will execute those expressions and it will display to you. And a processor, it will contain a very high storage elements called as registers, and inserting data into registers and accessing the data from registers is a very fast process. And it is always used for temporary storage. Once the program is executed and once it is the program is terminated, then whatever data is present in registers that will be removed. And here each register, it will store one word of data, and usually we represent the registers as R1, R2 and so on. So each register will store one word. So one word is equal to here 8 bits. And these 8 bits will be in terms of zeros and ones. Example. So totally 8 bits are there. So whatever, suppose we have um, given some input from keyboard for one symbol. Suppose we have given for some T. So this will be understood by the computer with the help of some bits. It will allocate. It has some internal numbering for each and every letter, for each and every operator. Some fixed notation of zeros and ones will be there for computer. So it immediately converts these letters into bits, and then it will store it as one word in the memory. And whenever we use registers, these are actually 5 to 10 times faster than the normal memory. Then we have control unit. Control unit will try to transfer the or it will try to move the control between input and output devices. Like when you are giving some input through keyboard, then control will be with the input device. Okay, so input device, which is our keyboard. Okay, then control goes to processor. Where whatever expression you are trying to evaluate, that will be executed, and control will be there with the processor. Once a result is obtained, it will be sent to output device, that is monitor. Then control will move to output device. So in this way, control will move from one module to other, which is done using control unit. And for this, synchronization signals are generated, which helps some control to move from one module to other. So with the help of this, when the control is moved from one module to another module, control unit is able to maintain order and direct the operation of the entire system. And these are other auxiliary modules. So here we have different types of storage devices. We can use hard disk, DVD, okay, pen drives. These are all the sources of external memory devices. And among all these, only hard disk is stores the data permanently on computer. And we also have optical disk, which helps to store the data again. And here we have two other additional modules, which are linker and loader. So whenever you write the program, whenever you are asking the computer to perform some job, your total instructions will be divided into submodules and they will be stored in the memory. Now, wherever memory is available in the processor, in the CPU, so suppose this is module 1, module 2, module 3, and this is a total program. So module 1 will be stored at some location because memory is free here. Module 2 result is stored in some other location. Module 3 result is stored in some other location. So each one is, why we are calling this as modules, because each one is working independently. The result of M1 is present within these lines of code only. Then M2 is working independently within these lines of code. Then similarly M3. M1 result is not dependent upon M2, or M1 works independently. Then we divide the program into modules. So this modular programming will also be done by the C program. Now this is stored in some address, the result of module 1. This is stored in some other address. This is stored in some other address. So when you try to see the output of the total program, so linker will store each of these modules. It will execute each of the modules separately. Results is stored wherever space is there in the memory. They are not stored in an order. So that is the job of the linker, to find out the space wherever it is empty and store this particular result of these modules along with the program name. Suppose the program name is some sum of two numbers. So for the sum of two numbers, it will indicate that this is the first module, this is second module, and this is third module for the sum. And when you try to fetch the result of the total modules, then loader will come into picture. Now loader, it tries to fetch the result from M1, M2, M3, and then it shows the result as the total result of the program. So loader will find out, or it will extract the related modules of this program with the help of this address. So linker will just assign these modules in the different free memory blocks, and loader will try to fetch the result from each of these modules. So this is about the different modules of the computer. Then we will see about the generations of the computer. So this is the first generation computer, which was introduced during the period 1940 to 1956. So here computers were realized using vacuum tubes, where within the vacuum tube you have a small electric circuit and some magnetic drums are there, which are actually storing the data, the input and output data. So this is a picture of the particular vacuum tube. But the thing is, they generated a lot of heat whenever computers were used. And examples of these devices are UNIVAC and ENIAC computers for the first generation computing devices. Advantages of this it is an only electric device, and it is the first device to hold some memory. And the drawbacks is it is to build a computer, it was taking a large space, and vacuum tubes they burn frequently. Why? Because they are generating lot of heat, and the maintenance problem was there. Second generation computers were introduced during 1956 to 1963 period. So instead of vacuum tubes, transistors were used here, and they were also using some type of a machine language, which is cryptic binary machine language, to understand the input which are given by the user. And examples of these are COBOL and Fortran. And they were also storing some instructions. So this is an example of second generation. So transistors were used here. And advantage is when compared to the previous one, size is less. The space they were occupying was less, and it was a little bit faster and reliable. And drawbacks are they also uh, get overheated quickly, and still maintenance problem was there. And coming to the third generation computers, it was during 1964 to 1971, where transistors were replaced with integrated circuits. And that is the size of the transistors was reduced, and it was attached with some silicon chips which are called as semiconductors. And an prototype of operating system was also developed. And punching machines which resemble the keyboards were also developed, and it helped to run multiple applications at a time. So this is the structure of third generation computers. So integrated circuits were less very small in size, improved the performance, and the production cost was also less. And ICs were sophisticated, and that was only drawback here. And fourth generation computers, presently what is running is during 1971 to present. Now the microprocessor were used, which was built using silicon chips. And we have the central processing unit, and we have the lot of other devices attached, like mouse, handheld devices. And this is the fourth generation computers. And fifth generation computers are based on artificial intelligence. Um, there are some applications like voice recognition, where applications are built using this fifth generation computers. And they also supported the parallel processing. And applications like natural language processing is also supported. And these are the fifth generation computers. So this is all about the generations of the computer, students. This is about the computer languages. We can categorize the programming languages, different types of programming languages, into three types: high level, middle level, and low level. High level languages, these are used to write application programs. And examples of these are BASIC, COBOL, Fortran. And the next one, middle level language. It is used for writing both application programs and system programs. System programs means the operating systems which are working at the background. For that also we can write some programs. So that is those are all the system programs. And the low level languages, these are used only to write the system programs, no application level. And these are called as assembly language or assembly level languages. So initially, low level programming language was developed. Then On the advancement, this high level and middle level language were developed because there was some difficulty in the low level language. So coming to the programming students, for any programming language, there are some series of steps or procedures which we need to follow to write a program. So those are called as the stages where you start writing the program. You take some input, you write some program, you process the data, and then you generate some output. So all these steps, phase wise, those are called as software development lifecycle or SDLC, which help you to create an application. The stepwise manner, how you write a program, how you fetch the output, all those uh, will be called totally as software development lifecycle or SDLC. And for writing the program, any new program, C or any other programming language, we can take the help of algorithm and flowchart. Before starting writing the program, you can go with algorithm and flowchart. Now, this will help you to write the program. You initially write some raw steps before writing the program. Write some raw steps that what can be the thing which we have to do, what can be the logic for writing this program, and then you try to convert the steps into programming language. So here we take the help of algorithm and flowchart for writing the any type of program. Some students related to summary. In this lecture, we dealt about input, output, arithmetic logic unit, control unit, and memory. These are the 5 essential components of any computer. And we have also come across the 5 generations of computers and what are the merits and demerits of that. And we have gone through the different types of languages. All the programming languages can be classified into 3 types. Middle level language. These are the programming languages which help you to write the applications as well as system programs. High level programming languages. These are the programming languages which help you to write only the applications, and then low level languages. These are for normally assembly level languages are called as low level languages. So students, let's have a small questionnaire here. Yeah, the 4th generation was based on integrated circuits. So we have already discussed this one. So what is the answer? Just take a few seconds and try to answer whether it is true or false. So the answer is false here. Okay, so 4th generation is not integrated circuits. If your answer is correct, then go to the next slide. Otherwise, just go back through the previous slides. Among these, which is the high level language? Yeah, try to answer these students. So high level languages are, all these programming languages are high level languages. After completion of this lecture, students, you will be able to illustrate the basic programming steps with the help of flowchart and algorithm. So this is our lecture outcome. And these are few lecture level questions. Explain the generations of computers and explain the components of computers.